Hi, everybody. I hope everything's going well. Bringing you a second hour pre-calculus social distancing edition today. I'm going to give you a quick rundown of solving systems of equations with Cramer's rule. We've done systems of equations in Algebra 1 and Algebra 2, linear systems. And we've done it with elimination and substitution, things like that. Well, now we're going to solve them with matrices because that's what we've been working on lately in our current unit. So um, again, we're solving a system of linear equations using what's called Cramer's rule. To do Cramer's rule, we're going to be using determinants of matrices. So right here, we've got a system of linear equations. We could solve it, by just graphing it on Desmos and seeing where these two linear equations intersect. Or we could use elimination or combination. But the first thing that we need to do if we're going to solve using Cramer's rule is take this system of equations and create three different matrices. The first matrix we need to create is the coefficient matrix. We've got 1, -3 in the first row, and -3, 6 in the second row. And hopefully you can see where these numbers are coming from, right? 1 and -3 in the first row are coming from the coefficients of the variables in the first equation, and -3 and 6 are coming from the coefficients of the variables in the second equation. Now we've got the 5 and the 8 highlighted here because we're going to start using those in our next two matrices. Second matrix, we're going to substitute out the x value coefficients, 1 and -3, and in their place, we're going to put the 5 and the 8 from the solution side of our system. And then you probably can guess what's going to come next. Our third matrix that we're going to create, we're going to take 5 and 8, and we're going to substitute those in for the y values in the coefficient matrix. So instead of -3 and 6 here, we got to have 1 and -3 for x values in the front. But instead of the -3 and the 6 in the second column, we've got our solutions, of the solution side of our system here. So the next thing we have to do is find the determinant of each of our three matrices. Remember the determinant, we're going to go A times D minus B times C in our matrices. So for our coefficient matrix, we're going 1 times 6, subtract -3 times -3. And the easiest spot to make an error here is with our signs in the second half of our determinants. So we've got 1 times 6 is 6, -3 times -3 is 9. We're going 6 take away 9. We get -3 for the determinant of our coefficient matrix. Now we need the determinant of our second matrix here. We're going 5 times 6 gets us 30. 8 times -3 gets us -24, but we're subtracting -24. So it's really going to be addition. 30 minus 24 is 54. 54 is the determinant of our x value matrix here. Then the determinant of our y value substituted matrix, we've got 1 times 8 is 8. We've got 5 times -3 is -15, but again, we're subtracting a negative. So 8 plus 15 will give us 23. So now we're going to actually use those determinants to figure out what our x value is and what our y value has to be, so that our x and our y value that works in both equations. It makes each equation true, or it's the intersection of the two lines essentially. Okay, so to solve this is really simple. What you're going to do is, to get your x, is you're going to take the determinant of your x value matrix and divide it by the determinant of your y value matrix. So we've got 54 divided by -3. -18 is going to be the value for x. And then you probably can guess, to get your y value for this system, your y solution, you're going to take your determinant of your y and divide it by the determinant of your coefficient matrix. So now we've used that 2 times, right? And now over here we've got 23 divided by -3, which we can't really simplify. It's going to be like -7 2/3. And I wanted to give you guys kind of a messy one so you can see it's all not